So this video is going to talk about something in geometry called Cpctc, and it's actually probably quite intuitive to you, but because we're dealing with geometry, which is a logical, deductive reasoning based strand of math, we need to have a clear name and definition for every property, phenomenon, theorem, postulate that we observe so that everyone can talk about it with a common language. And Cpctc is that common language for this phenomenon that we're about to discuss. So look at this diagram based on what you've learned. The question is, are the two triangles congruent? And you might say, yes, of course, they look congruent. But again, deductive reasoning, we have to have a reason based on the bank of theorems, postulates, properties that we know for sure are true to justify it. So let's think back for a second. You've previously discovered in your learning, hopefully before you're watching this video, 4 shortcuts, in our class at least, for showing that two triangles are congruent. What were they? That's right, I heard side, angle, side. What's another? Yep, angle, angle, side. Oh, yep, side, 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 I heard that. And finally, angle, side, angle. And obviously I'm kidding, nobody's talking to me while I'm making this video, but hopefully you were shouting those things out as you were watching. There is a fifth one, it's called HL, but we haven't talked about that yet, so let's just keep that off to the side for now. So, which of these 4 reasons justifies why these triangles are congruent? Well, I see side, side, so that's one S, because we're always talking about pairs with these acronyms, side, angle, angle, side, angle, side, angle. See another, it's another S, that's SS, it's not one of them. But wait, vertical angles theorem, vertical angles are congruent, boom. We have side, angle, side. Justifies that these triangles are congruent. So now based on the fact that these triangles are congruent, I want you to pause the video and take 10 seconds to label everything now that you know is congruent based on the fact that the triangles are congruent. So you pause the video, you labeled everything in the triangles that you think are congruent, and intuitively, you probably know, oh, okay, so now these are congruent, and these are congruent. Now let's emphasize why that is, because what we showed by side angle side is that RWT is congruent to triangle RW. RWT goes along the double mark side. No, sorry, not RWT, RWS. That goes along the double mark side and then the single mark. So we'd also have to say TWV because that goes along the double mark and then the single mark. So RWS and TWV, the reason I say that is because angle R matches up with angle T in the order. That's why they're labeled congruent on the diagram. And angle S matches up with angle V in the order. So that's why they're marked congruent to each other on the diagram. So that's everything we know based on showing that the triangles are congruent by side, angle, side. And that's essentially what Cpctc is. So before we state it out in words, let's just summarize everything we just said. So we said angle R is congruent to angle T. We said angle S is congruent to angle V. That leaves angle W must be congruent to, well, we need to name it with 3 letters, otherwise it's unclear. Angle RWS is congruent to angle VWT. And we also know that line segment RW is congruent to line segment WT. Line segment VW is congruent to line segment SW. That was already given. But this new piece of information that we've learned, marked right here, that we intuitively marked, is that VT is congruent to RS. So all of this information that I'm highlighting in yellow, we already knew at the start of this problem. No, we didn't know that. Sorry. We knew at the start of this problem that RW was congruent to WT. That was already given. And we also knew that VW and SW were congruent. Then we used vertical angles theorem to show that these two angles were congruent. But all of this that we just came up with Well, that's due to this new property right here, Cpctc. So what does Cpctc stand for? Excellent question. I'm glad you asked. Cpctc stands for corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. But when do we use it? Once we've proven two triangles are congruent, then corresponding parts of those triangles are congruent. So first we have to show the triangles are congruent by side, angle, side, angle, side, or side, side, side. Then we can use Cpctc to talk about their parts. So let's look at a couple examples. See how we're doing on time here. All right, so here I'm given that angle ZXW is congruent to angle YWX. So ZXW, that's this angle right here, is congruent to YWX. This angle right here. Let me not use highlighter. And I'm also given that angle ZWX is congruent to angle YXW. So ZWX, that's this big angle, is congruent to YXW, also this big angle. And that's a little hard to visualize for me because I have these overlapping triangles. So anytime I have overlapping triangles like this, I always want to draw it out as two separate triangles. And you should always do the same thing. That would be my recommendation to you. So disclaimer, drawing not to scale. Obviously those don't match perfectly, but as long as I put the letters there, we've got the idea. So the red markings would remain there, and the green markings would now be here and here. Now it's a little easier to see where we're headed with this proof. Now notice our goal here is a little different. I'm not trying to show the triangles are congruent, I'm trying to show that parts of those triangles are congruent. And again, it looks obvious, possibly to you, but we have to justify it. We're a lawyer in the courtroom and we have to, with beyond the shadow of a doubt, explain why that is true using the postulates, theorems, properties that we know for certain are true in geometry. So let's go ahead and do that. So obviously we start with the given. Oh, sorry. So I'm just gonna move this given down to here. Not write it twice because that's gonna make this video take too long. That's given. We already marked it in the diagram, so we're on to the next thing. So first I want to show the triangles are congruent because we said we have to do that first before we use Cpctc. So well, let me give you this broad overview first. So basically, I can use angle side angle as you see in black, or side 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 as you see in red, or side angle side as you see in blue, or angle angle side as you see in green to show that two triangles are congruent. Once I've shown that two triangles are congruent by one of those four things, angle side angle, side side side, side angle side, and angle angle side, then I can use Cpctc to talk about the parts that I previously didn't know. So in the blue triangles example, we knew that one side, one angle, and another side was congruent to one side, one angle, and another side. But we could use that to show that the triangles are congruent by side angle side. Then we could use that to say that these third angles were congruent by Cpctc. So you see the process, it has to first be one of the four things, angle side, side angle side, and then angle angle side to show the triangles are congruent. Then once we've shown they're congruent, we can use Cpctc to talk about their parts and justify why those parts are congruent. So here, first we have to show that the triangles are congruent. And anytime I have overlapping triangles, they're always going to share some part. So would you look at that? These two triangles share that side. So I can go ahead and mark that. WX is congruent to WX. It's the exact same side if I pull the triangles back together. So that's just the reflexive property. And then finally, based on that, not finally, sorry, next step, based on that, I can say that the triangles, so triangle ZWX is congruent to triangle YXW by, what have we shown there? Which of the four options? Angle, side, angle. And now here's where I can bring in my proof statement. So now that I know the triangles are congruent, I know that these angles must be congruent. I know also that the remaining sides that correspond must be congruent. So ZW is congruent to YX due to Cpctc. Corresponding parts of congruent triangles are congruent. So I'm done with that particular proof. All right, so again, first show the triangles are congruent, as I've done here in column 1. Then, after you've shown they're congruent, you can use Cpctc. So it's a two-step process, basically. All right, one more example. So let's do this one as a paragraph proof. So I'm given that AD is congruent to CB. Always got to mark it in the diagram, AD, CB. I'm given that AB is congruent to CD, AB, CD. Also need to mark that in the diagram. And my goal is to prove that angle A is congruent to angle C. Those are parts of triangles right here. So first I need to show that the triangles are congruent. So I can start by stating the given. So from the given, we know, and I'll be thorough on this one, AD is congruent to CB and AB is congruent to CD. So where can we go from here? Well, anytime triangles share a side, bang, I know that DB is congruent to DB from the reflexive property. So now, which of the four options have we shown for why these triangles are congruent? Triangle ADB is congruent to triangle, all right, so ADB, that went along the single mark, then the triple, so I need to go along the single, then the triple, CBD. So triangle ADB is congruent to triangle CBD by, what have we shown there? Yep, that's side, side, side. Now, here's where the new stuff comes in. Therefore, angle A must be congruent to angle C by what justification can we provide for that everyone's going to understand in common terms what we're talking about? That's right, Cpctc. So hopefully that helps give you a good understanding of what Cpctc is. So again, just to reiterate, first you show that triangles are congruent using one of the four reasons highlighted here in yellow: angle, side, angle, side, angle, side, 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 or angle, angle, side. And then you can use Cpctc to state that any remaining parts that we didn't already know are congruent are for sure, beyond the shadow of a doubt, congruent. Thanks for watching.